Statistics is the science of collecting, organizing, and interpreting data in order to draw inferences. So, to remember that, I use this mnemonic COIN. And the CO and maybe part of the I, that kind of deals with descriptive statistics. And then the N is a phonetic, and the N deals with inferential statistics. And we'll see that as we progress along. But the basic difference between those two is whether or not we're drawing conclusions, making decisions, and the category where we're making conclusions or making decisions or drawing conclusions, that would be the inferential part of things. And then the first part or type of statistics are descriptive statistics. Okay, so let's start there. And so descriptive statistics basically involves organizing data so that you can, have more than just raw data. So it deals with graphs and charts and trying to summarize numerically the data, or maybe in tabular method. There are several different ways to summarize data, and we will see those. But so again, broadly speaking, there are two big parts of statistics: descriptive statistics and then inferential statistics. And the inferential, again, is where we're making decisions. So let's see. In this first example, we're looking at a baseball season in 1948. The Washington Senators played 153 games. They won 56 and lost 97. Okay, so they finished 7th in the American League and were led in hitting by Bud Stewart. I don't. This has been too long ago. But Bud Stewart's batting average was .279. So the baseball statistician, whoever was working at that time, would have put all this together. And so here's an example of descriptive statistics, because this data is not being used to make a decision, to draw a conclusion. It's just sort of summarizing the baseball season. Okay, so a big part of statistics is, how do we, what methodologies do we use to learn more about whatever it is that we're interested in? Because most of the time, the set of objects about which we want to know something is just so big, and that set is the population, by the way. That's the total set of units or objects about which we want to know something. And like I said, usually that set is so big, it's just infeasible to gather data from each unit in the population. So what we do is try to look at a subset, but we can't just look at any subset. We want to try to put together a subset that is a microcosm. And that's a big word. I would encourage you to go look it up in the definition, but essentially what a microcosm is just like a mini version of some bigger set. So we would like a sample, that's the smaller microcosm. We would like a subset of people, usually it's people, that possesses the same characteristics as the population, that has similar traits or whatever, so that if we learn about the sample, then that will inform us, hopefully, about the population of interest. All right, so here in example 1.2, we're looking at political polling, and this, according to what they say here, is an example of inferential statistics. And so if a person is interested in learning something about the current setting or how people feel in the U.S., voting preferences, etc., then to interview every person in the U.S. would be unrealistic. And so again here, statisticians would want to look at a small a smaller subset of the U.S. or whoever can vote, the voting population, and hopefully get a sample that is representative. That's another word that basically means the same as a microcosm, because again, we want this subset, this sample, to possess similar characteristics to the population. So we would like to get a sample, and we would like the distribution of, let's say, Democrats or Republicans or whatever, conservatives, however you want to divide people up in terms of their politics. But we would like the sample to possess very similar characteristics to the population, so that we can get an idea, about what's going on with the population. And again, inferential statistics essentially is where we're drawing conclusions. So not only drawing conclusions, but also measuring the reliability of those conclusions, like how, like once we draw a conclusion or make a decision, then how comfortable can we be with that decision. Now, that is something that we will do more of later on and towards the end of the course. So for the first part, we'll be doing a good bit of descriptive statistics, just getting used to what types of graphs and charts there are, and then what are the common ways to summarize numerical data, how would we summarize quantitative data, and then what are the types of data and things like that. And so, but later on we'll look into the inferential side of things. And there's a nice figure to illustrate the population of the sample. All right, so example 1.3 is about classifying statistical studies. And this is a summary of the voting results in the 1948 presidential election. Well, that's going way, way back there. But this is a descriptive because this data is not being used to draw a conclusion or make a decision, right? It's just data that's been summarized in a more readable format.